everything Wi-Fi and CAT cables, 2G to 5G, Wi-Fi 5 and Wi-Fi 6, 802.3AF, PoE, 802.11a, B, BG, and N, as well as CAT 5 through 6. 2G to 5G, all generations. 2GE, or 1X, the icons G or E for GSM, or 1X for CDMA, represent minimal 2G service levels, with connection speeds of 50 to 400 kilobytes per second only. 3G, Universal Mobile Telecommunication Service, UMTS, on a GSM handset or Evolution Data Optimized EV-DO on CDMA networks working at up to around 3 megabytes. High-Speed Packet Access, HSPA, provides improved 3.75 gigabytes data rates on GSM networks. Nominally, HSPA Plus can work at up to 42 megabytes per second, but real-world performance is likely to be lower. 4G, 4G LTE. 4G LTE Advanced has a maximum downlink of 300 megabytes per second, in theory, but no provider networks can deliver that sort of speed at the time of writing, with around 20 to 90 megabytes per second typical of real-world performance. 5G. Real-world speeds are nowhere near the hoped-for 1 gigabyte rate, ranging from about 50 megabytes per second to 300 megabytes per second at the time of writing. What is Wi-Fi 5 and Wi-Fi 6? Wi-Fi 5, 802.11ac, is designed to work only in the 5 GHz band. A dual-band access point can use its 2.4 GHz radio to support clients on legacy standards, 802.11g/n. A tri-band access point has one 2.4 GHz radio and two 5 GHz radios. Wi-Fi 5 allows up to 8 streams, though in practice, most Wi-Fi 5 access points only support 4x4 streams. A single stream over an 80 MHz channel has a nominal rate of 433 megabytes per second. Wi-Fi 5 also allows wider 80 and 160 MHz bonded channels, 1000 megabytes per second over a 40 MHz channel with 2x2 streams on the 2x4 GHz radio, 2166 megabytes per second over an 80 Hz bonded channel with 4x4 streams on the first 5 GHz radio, and 2166 megabytes per second on the second 5 GHz radio. Wi-Fi 6, 802.11.ax, improves the per stream data rate over an 80 MHz channel to 600 megabytes per second. As with Wi-Fi 5, products are branded using the combined throughputs of all radios. For example, 802.11.ax claims nominal rates of 1,148 megabytes per second on the 2.4 GHz radio and 4,804 megabytes per second over 5 GHz. Wi-Fi 6 works in both the 2.4 GHz and 5 GHz bands, though Wi-Fi 6E standard adds support for new 6 GHz frequency bands. 6 GHz has less range but more frequency space, making it easier to use 80 and 160 MHz channels. Wi-Fi 6 introduces another technology to improve simultaneous connectivity called Orthogonal Frequency Division Multiple Access, OFDMA. OFDMA can work alongside MU-MIMO, multiple in, multiple out, to improve client density, sustaining high data rates when more stations are connected to the same access point. 802.3 AF AT AB / PoE, Power over Ethernet. Power over Ethernet, PoE, is a means of supplying electrical power from a switch port over ordinary data cable to a powered device, PD, such as a voice over IP, VoIP, handset, camera, or wireless access point. 802.3 AF AT PT PoE, Power over Internet. 802.3AF allows power devices to draw up to 13 watts. Power is supplied at 315 MA at 48 volts and limited to 15.4 watts, but the voltage drop over the maximum 100 feet of cable results in usable power of around 13 watts. 802.3AT PoE Plus allows power devices to draw up to about 25 watts with a maximum current of 600 mA. 802.3BT PoE++, or 4P PoE, supplies up to about 51 watts Type 3 or 73 watts Type 4 usable power. 802.11 all generations and Wi-Fi 4. 802.11a has 5 GHz frequency bands. The IEEE 802A standard uses the 5 GHz frequency band only. The data encoding method allows a maximum rate of 54 megabytes per second. The 5 GHz band is subdivided into 23 non-overlapping channels, each of which is 20 MHz wide. The nominal indoor range for Wi-Fi over 2.4 GHz is 45 meters, 150 feet, and 30 meters, 100 feet, over 5 GHz. 802.11b, 2.4 GHz frequency band. The IEEE 802.11b standard uses the 2.4 GHz frequency band and was released in parallel with 802.11a. The signal encoding methods used by 802.11b are inferior to 802.11a and support a nominal data rate of just 11 megabytes per second. 802.11b/g. The 802.11.g standards offer a relatively straightforward upgrade path from 802.11b, uses the same encoding mechanism and 54 megabytes per second rate as of 802.11a, but in the 2.4 GHz band used by 802.11b and with the same channel layout. This made it straightforward for vendors to decide 802.11g devices that could offer backward support for legacy 802.11b clients. 802.11n Wi-Fi 4. The nominal data rate for 802.11n is 72 megabytes per second per stream, or 150 megabytes per second for a nominal of 40 megahertz bonded channel. And 802.11n access points are marked using NXXX designations, where XXX is the nominal bandwidth. As an example, an N600 2x2 access point can allocate a bonded channel to streams for a data rate of 300 megabytes per second, and if it does this simultaneously on both its 2.4 and 5 GHz radios, the bandwidth of the access points could be described as 600 megabytes per second. In recent years, Wi-Fi standards have been renamed with simpler digit numbers. 802.11n is now officially designated as Wi-Fi 4. Cat cables 5, 5E, 6, 6A. Cat 5, 100 megabytes per second, up to 100 meters, which is 328 feet. 100 base TX fast Ethernet. Cat 5E, 1 gigabyte per second, 100 meters, which is 328 feet. 1000 base T gigabit Ethernet. Cat 6, 10 gigabytes per second, 55 meters, that is 180 feet. 10G base T, 10G Ethernet. Cat 6A, 10 gigabytes per second, 100 meters, that is 328 feet. 10G base T, 10G Ethernet. What are Cat 5 and Cat 6 cables? A Cat specification is a particularly twisted pair cable construction method rated for use with given Ethernet standards. Higher CAT specification cable is capable of higher data rates. CAT specifications are defined in the TIA/EIA 568-C Commercial Building Telecommunications Cabling Standard. What are Cat5 cables? Cat5. The CAT specification is printed on the cable jacket along with the cable type, UTP or F/UTP. For instance, Cat5 cable supports the older 100 megabytes per second fast Ethernet standard. It is no longer commercially available. A network cabled with Cat5 will probably need to be rewired to support gigabit in Ethernet. Cat5 would still be an acceptable choice for providing gigabit Ethernet links for clients' computers, but most sites would now opt to install Cat6 cable. The improved construction standards for Cat6 mean that it is more reliable than Cat5e for gigabit Ethernet. It can also support 10 gigabytes per second through over reduced range. What makes Cat6 so special? Cat6a supports 10 gigabytes per second over 100 meters, but the cable is bulkier and heavier than Cat5e and Cat6. And the installation requires more stringent, so fitting within pathways designed for older cables, it can be problematic. TIA/EIA standards recommend Cat6a for healthcare facilities with Power over Ethernet (PoE) 802.3bt installations, and for running distribution system cables to wireless access points.